Thanks, Edley. Everybody here at the back? This talk is about deploying high availability software using SaltStack and some very domain-specific problems. My name is Petrus. I've got a background in engineering, and I currently work at CodeBridge, which is a shared hackerspace in Claremont, just down the road. Great place for events. Mike also started working on the way there, so you're all welcome to come by and join one of our events, especially about architecture. I really care about user experience on the web, and I also manage a lot of domain names. Who here knows this form? Or owns a domain name, .co.za specifically? Yeah, real painful. Most of the audience has a domain. And I specifically love the bit about don't edit this with a word processor. And you have to update name servers using this form. There must be a better way. The reason I'm talking about this is because it's really painful for me to manage all my domain names. And all the existing registrars really suck at user interface or bulk management. So I was willing to put some of my own money down to make this happen, but it doesn't exist. Until now. MyNames is a bulk.co.za domain management service that's built entirely in Python, deployed on Amazon Web Services, and uses SaltStack for infrastructure management and TeamCity for continuous deployment. Now I'll go over some of our architecture, and I'll tell you a bit more about Salt and a brief overview of TeamCity. The design goals I had for this service was to have one-click domain registration, really easy and solid DNS. That's why we're using Route 53 for our service, for our customers. Update your contacts easily, and to make it really easy to do automated renewals. Never to lose a domain again because you forgot to pay for it, which has happened to me, and it's worse when it happens to one of your clients. So we've managed to solve the top 4 problems already, and we're working to solve the last 2, which is to consolidate billing and make email really easy as well, specifically email forwarding. I should state this product is not vaporware, but it is in progress and it's being built actively. Pierre, Hugo's in the audience, and Yassine all helped build out the initial prototypes. And I'm going to tell you a bit more about our internal architecture. So this is an overview of our system. Somewhere we have a central registry, and we talk to it. We have a web interface that takes traffic in, passes it to an API. These 2 things run on separate domain names. Lots of cause headers moving around. And some workers make it happen to synchronize domain and contact state with the central registry. And for our state, a consistent state, we use RDS, which is just a hosted MySQL service. The magic in speaking with the registry, that's EPP. It's this lovely XML protocol. Just pain. And so we've solved that problem already. One of the interesting design constraints that we have is that we can only make 2 simultaneous TCP connections to the central registry. And these are typically rate limited and bottlenecked. So anyone who's trying to check 1,000 domains at once, or to register domains or update their contact, has to go through these, at least only 2 workers. We have some principles that we designed the system around for the purposes of high availability. And I should state, this is not a web scale service. We're not looking to have millions and millions of users. I just wanted to solve this problem for myself and have it never go down. So high availability is focus here. And when you do bring up something that went down, it shouldn't break anything. It should just work. So any commands that we execute after bringing something back up should not have any side effects or mess up the order of stuff. And it should have a sensible UI, RESTful API, and that our UI uses to interact with it. So let's design the system. We have some instances running on EC2. 4 API instances can be 2, can be 3, can be 10. And we have a load balancer which takes in our web traffic and distributes it using round robin to our instances. And somewhere we have to communicate with the central registry. So before we can do that, we need to keep track of state. So let's add a database. In this case, it's MySQL running on RDS. And some external services like Route 53, which we use to manage our customers' DNS. But we still haven't talked to the registry. So if we add our 2 workers, they can now talk to the DB and they can talk to the registry, but when do they know to update anything? So somewhere a command needs to be sent, and that's where we add a command queue, which runs on SQS. SQS is not very fast, but typically we are not constrained by that type of latency in registering domains. Our first design for this queue and the way we manage commands was quite naive. We would put in commands like register or update these name servers or change this contact, and our workers would pick those commands up. And that worked fine for a while, but pretty soon we had ordering problems when we tried to bring stuff down and back up again, because these functions, these commands had side effects. If you say my phone number is 123 and now you say it's 456, if any of those commands fail, what do you do with the command? Do you put it at the back of the queue? Do you hold up the queue? The ordering is no longer consistent, and you don't know what the true value of your resource should be. In our case, mostly contacts and domains. So let's try something else. We now have idempotent commands, which mean they have no side effects. Typically look like sync this domain or sync up this contact and make it happen. And you'll notice we've added a command handler to our worker block, which takes a command like go sync up example.c.za, and it'll figure out all the things it needs to do to bring it up to the state that we want it to be in. So we can now safely bring down a component and bring it back up again, and we can issue as many sync commands as we want and nothing will break, because like, this is exactly what it should be, or this is different, let's make it happen. So we have to test our command handlers really well, but other than that, our system has now become a lot more robust because of the nature of our commands. A really interesting pattern we discovered, I don't know if it's novel, was in how we keep track of resources that have eventual consistency with some external resource, the central registry in this case. When you have a domain like example.COZA, you have some desired state. Like I want it to be registered, or in this case, let's say it's already registered, and I want it to be deleted. But that's not enough. You also have to know what the true state is, because the true state lies with the EPP registry. So you have to add another field. We've got the desired state, and I've got my true state. And from this, I can like build a command that says, it's a domain, delete this domain because I want it to be deleted when next the sync comes in. But if you want to show this to the user, you don't really know if it's happened yet and when it's going to happen. So you need another field, which we call the last result. And the last result is one of pending, succeeded, or failed. And using that, you can already start to build a UI of, here you have 100 domains, this is syncing, it's not done yet. But it's still not clear enough. So using timestamps and the consistency of our database, which has the properties of ACID, which means it's consistent, we can add a dirty field, which we calculate from timestamps. And using this information, we can show a very nice, consistent UI using coloring, as so, for all your domains. So stuff that's exceeded are green, is green. Stuff that is yellow hasn't happened yet, and if it's red, it failed. And it can be any, you can use this type of pattern for a lot of systems that have an external service that you need to talk to, and you may only talk to it much later or tomorrow while it's down. And you can show it a consistent state to the user with a simple UI. Our deployment flow for MyNames has been to use a Git Mercurial repo, which pushes code into TeamCity, or TeamCity actually polls. Polls is typically better strategy than push. It runs our tests, packages artifacts that are ready for deployment, and notifies our salt master, which I'll go into in a bit, to distribute the code to our minions. Our minions are all our instances running the code with various roles doing stuff like syncing domains or listening for API requests. And I'll tell you a bit more about Salt. TeamCity is a continuous integration server that runs on Java. It's a lot like Jenkins, but it actually has a pretty UI. I prefer it. I think it's far superior. It also supports Java and .NET stuff, which you'll have a hard time with on Jenkins. It runs all our tests, and only if tests pass, all of them, after logging it, will it trigger a deploy, which is done by the Salt master. So let's go a bit more detail into Salt. Salt is a client-server-based infrastructure management software. It's different from a continuous integration server like TeamCity, in that it manages your fleet of instances. The master is called the Salt master, and you can have multiple instances connected to one or more Salt masters, and they're called minions. The Salt master does package management for you like Chef. you can specify a state and say, I want Vim to be installed, and if it's not installed, it'll install it. If you say, I don't want it to be installed, it'll get rid of it. And it does so for multiple platforms. It's entirely written in Python, which is always nice, especially if you want to extend it. And I've done that, to talk to specific EC2 stuff, to pull in stuff from the console, like roles of workers. It replaces a combination of tools like Fabric and Chef. And, well, it's an alternative to it, in that it can also babysit instances that are doing updates or executing code. So in that regard, it's like Fabric. One of the nicest parts of it, though, is the configuration management using a component called Pillar. So Salt Pillar, they really beat this to death. You can push environment-sensitive configuration files to your minions. It's really fast because it runs over 0MQ, which is a communications protocol. So let's look at some of the syntax. I won't be doing any live demos, but typically from the Salt master in the shell, you can ping all your minions. And we see here in this example that we have the master, which is also acting as a minion in this case. We've got one web node and a second web node, and they're all up, but there's a third node that's dead. And that could be because Amazon's instances keeled over, happens all the time, and we can now respond to that and provision another instance, which is something Salt can also do for you. So why should you use Salt? I find the syntax to be easier than Chef. It's YAML based, but there are other renderers like JSON that can interpret, or XML, depending on what type of flavor of configuration you prefer. It manages most platforms, including even Windows packages. And you can do really fancy targeting of minions based on their name or certain properties of them, and I'll go a bit more into that, specifically the grain system. The configuration templating is really powerful for us because the architecture that I showed you, we have literally a duplicate of that for our QA environment and for our testing environment. So without messing with our production domains, because domains are really important for people, because email depends on it, we can test stuff with a clone of our architecture, and Pillar just knows, this is environment database connection string, or this is this DNS or API URL that I need to write to the config file. The tool can also provision Salt cloud instances using an internal tool called Salt Cloud, and it works for up to like thousands of minions because of the way the protocol is implemented. But for us, we just have a small fleet of instances, works just as well. There's also a crazy overstate system that I haven't even used, but you can stagger deploy. So you can say, I want you to first roll out these DB roles, and if they fail, don't do the web thing. Or do the backup first, and if the backup works, then go onto the database deployments and then to the web deployments. Some things that aren't so nice is that it's pretty new. So the documentation I found was pretty correct, but cryptic in cases. So you really have to hang around on IRC and talk to the developer, who's a super nice guy, and they'll give you a lot of guidance. So there are some breaking changes between versions because it's so young, and you do need a client on the minion, unlike a tool like Ansible, which talks with SSH forks, just talks directly over SSH, which is, I think, a superior tool for like small IT configurations or if you're running a school's network. But for us, it's not a problem because we control the infrastructure and we can have minions on all of our instances. OpsWorks supports Chef, but not other tools like Salt. So that may be a consideration for you if you're deploying on AWS. So there's an example of a state file. Remember, state files are what tell Salt how and what state the system should be. And this particular example is for Nginx, which we use to serve our static HTML. I'm really telling it to do two things. Naming the package ID as Nginx, which is then inferred to be the name of the package. I want it to be installed, and the service for this package should be running. In addition, I'm adding a dependency for this service that it should make sure that the package is first installed, and that there is a config file for it, which we template using Pillar. Lastly, if we do change this config file, it gets watched and it restarts the Nginx service automatically. So if we decide to change the way our UI loads, we can just change the template file, run Salt high state, and Salt knows to restart the Nginx service. This is how we target nodes. You start at base and you say, I want all of the nodes. The little asterisk means any name to have Vim and Git on it. And really cool thing starts to happen here where I have Ginger templating to conditionally deploy certain states. So when I'm working locally on my local box, I have all my source ready, it's up to date. I don't want it to override my source code with our GitHub hey, master. So I say if it's not the dev environment, please get the latest repo, and the repo means all our source code. Go put it in our my name's home directory. Lastly, our users. But how do you really drill down into different roles? So let's talk about targeting. In this case, I'm using the grain system, which is like properties for nodes. You can add and remove properties from different nodes or instances from the saltmaster. And I'm saying any node with the role EBP matching on its grain property should have the keys state and the EBP state. The EBP state is our service that takes care of our worker processes, and the keys are like secret, super secret passwords and stuff for dealing with EBP, which we don't want on our web services because they're more likely to be targeted by attackers. Hopefully we're popular enough to be hacked at one point, but if one node does get compromised, we don't lose all of our keys. And you can secure your salt stack in a similar fashion. We actually have two different repositories of code for our runtime code and for our salt configurations. It's a bit of a hassle keeping both up to date, but when we're deploying a repo to one of our web instances, we don't want it to have access to all of our production database connection strings. It's just an extra bit of security. In addition to the roles grain, we also have an environment grain for QA production and dev. And here I'm targeting that, so if it's in production, I want the New Relic state to be installed so that we can keep track of any memory and uptime on the box. So this is actually a Python file that gets templated with Ginger using the pillar configuration system. And so this gets, I tell Salt to output this on our web nodes in a certain folder, and our entire program reads this config in, and it uses the values in this file. For example, the base URL of our API, the database connection string, which is templated according to the environment that we're deploying on, whether that is production, local, or QA. So this is a visual depiction of roles on certain nodes, and you can update them at any point in time and tell Saltmaster to update the nodes for which the roles have changed. All right, so I've given you a bit of an overview of how our architecture works, with an emphasis on high availability and not necessarily web scale. And I'll show you some screenshots because I'm not going to be able to do a demo. This is the current state of the product. You can search for domains, it's really quick in mass. And you can, when one click buy domain, given that you have prepaid credit on our system. I found that works best for me because I'm buying a domain every day for a client. And I've implemented that UI so far. It's still in constant flux, but it's we're already showing some of my test domains. These are testing domains. They're not real.co.za's. And the state in which they are based on whether they're pending or deleted or not. So thank you so much for listening. You're welcome to, if you have a domain name and you're keen to try out our service, you can sign up for the beta at mynames.coza. Not quite ready for prime time yet, but you're welcome to get in touch and tell us more about your needs as a domain manager so we can build a really awesome service that not only solves my problems, but also your problems. Thank you so much.
Have we got any questions? Brandon.
Just for the salt side, you said that there's an agent in each node. How is that exposed? What do they talk? How security conscious are those agents?
Good question, Brent. So you don't want any minion connecting to your master and asking for source code. So every minion is authenticated on the master with a key that is randomly generated, and whenever a new instance comes online, every minion knows the name of the salt master, or some DNS value, or you can have an address that's pre-configured on every instance. When it connects to the master, you authenticate. You say, cool, I accept your key, and then an SSH type connection gets initiated. The protocol they speak is, I'm not sure, but it's over 0MQ, which is like a persistent TCP connection, I think, and it's really quick. Does that answer your question? I'd say it's changing a lot because it's pretty new. But it is reaching stability. We're at like, it's like version 0.14 or something. So it is, if you were a big shop, you may want to look at something more mature.
So you're just mentioning, security around your keys and stuff. I was just a little concerned about having a very alpha agent, which is listening to the web, sitting on every node there.
Sure, no, that is a concern. I think the source code is pretty well tested though for security, but I can't speak to that.
Any more questions for Petrus?
In the back here.
Yeah, there we go. JP.
So you say it's quite new. How does it compare userland module-wise to something like Puppet or to the chef scripts that you can find?
How does it compare
Userland-wise, like availability of things that you can do instead of having to do yourself.
Awesome, great question. So Salt, despite being quite new, it has support for, I haven't found a module that doesn't do what I wanted it to do. Like you can tell it, go template this file or start this service, or it doesn't integrate, I'd say, with as many external third-party services, but anything you want to do in terms of files or appending data to files or logging that I've had problems with, I've been able to solve with Salt. And failing that, you can always just have an SSH, a bash file that you send to your minions and execute that and monitor the execution of it if it's something that Salt can't do for you. We actually started off using Python, Puppet, and we switched because it was, I don't like the syntax. And
DSL is weird.
yes. I much prefer the YAML of Salt.
Then one other thing, the Puppet ecosystem has things like mcollective and Hira and everything else. This seems to bring a lot of that together in one thing instead of having tools that speak to each other.
Yes, so Puppet does really good package management, and I don't know if it does what Fabric does exactly, but Salt does do configuration templating, it does remote execution and command and control all in one. So it may be fewer moving parts for your shop if you're deploying to a lot of nodes.
I've got one. When you were developing mynames.coza, did you emulate the interaction with the domain registrar, or did you break many real domains while you were building it?
There is a test system that is equivalent to the normal system, and we spoke with that. For testing, we also have mocks of all of the XML responses that we expect, and they're just horrible. But that's how we built up the service initially, and so we made sure it was pretty tight, and we could do balance reductions and additions before we went live. We're not live yet, we're still testing internally.
How many domains do you actually manage?
Low hundreds, not like thousands. I mean, there are probably people here who earn way more than I do and have it with some ISP, and they probably get charged a lot for it too, and it goes down. So we want to solve that. So if you have a lot of domains, try mynames. One more question over here.
I want to ask the audience, how many domains do they have? Who has the most domains here? What's it like?
Who has more than 100 domains? Ashley has.
You. Who's administered?
Who manages more than 100 domains for someone or something? You. Some early adopters there. Back. That's great. Cool. All right. Thank you very much. It was great speaking with you. Unless you have another question.
I have another question. I was just going to say a big hand for Petrus.